So we are doing some AP review. This is a BC question from 2009 Form B. This is BC 4, which is a polar question. It is non-calculator. So the graph of the polar curve, r equals 1 minus 2 cosine theta from 0 to pi, is shown here. Poorly drawn by me, but better on the actual AP problem. Let S be the shaded region in the third quadrant, this tiny little bit, bound by the curve in the x-axis. Write an integral expression for the area of S. So you're not being asked to actually find the value of S. You're being asked only to write the integral expression for that value, right? And this is pretty common. So here's the deal. We need to start by figuring out the bounds of this region, right? So this is very clearly an endpoint for the curve, right? And you can see that this is what would happen if you plug in r of 0, right? Because you'd get 1 minus 2 times a1, which is -1. And sure enough, you get the polar point that is -1 comma 0, which is, sorry, that's a 0, not a theta. My bad. Hard to erase when it's this tiny. So theta is 0, meaning you start facing this direction and you walk backwards 1. Okay, so that's the first bound, right? So bound number 1 is theta is 0. Great. The question is, what's the other bound? Well, the other bound's going to happen at the origin, right? Because this region lands at the pole, or the origin, right? So the other bound is going to happen when r equals 0. So the question is, when does 1 minus 2 cosine theta equal 0? Well, that's when 1 equals 2 cosine theta, or 1/2 equals cosine theta. And based on our unit circle knowledge, what we're going to get is that that's when theta is pi over 3. So my two bounds here are 0 to pi over 3, right? So again, when I'm asked to write the expression for this area, the first thing I need are bounds. The second thing I'm going to need is to know the formula for the area inside a polar curve, which is 1/2 the integral from whatever my starting bound is to my ending bound, which I now know, but we'll just call them alpha and beta right now, of my r squared with respect to theta. So the answer to part A is that my area is 1/2 the integral from 0 to pi over 3, because those are my bounds, and my r is 1 minus 2 cosine theta quantity squared with respect to theta. That's what the AP wants. Now, if you had not been able to find this bound by visual inspection at the beginning, you could have spotted that the radius is a -1. It could have also been a radius of 1, but based on the bounds you're given, it makes sense that that bound was 0. All right, that's our part A. Let's talk about part B. So again, you're not asked to integrate, you're not asked to clean it up. This is exactly what the AP wants. All right, next part. We do not need the graph. I don't believe the rest. So next part, part B. Write expressions for dx d theta and dy d theta in terms of theta. So what this is going to require first is that you know the relationship between r and theta and x and y. So in a previous video we discussed in the unit 7 of BC Calc, and also in Algebra 2 Pre-Calc, we discussed that x equals r cosine theta, meaning that my x is 1 minus 2 cosine theta times a cosine theta, right? Because r cosine theta. And my y is r sine theta, which in this case is that whole 1 minus 2 cosine theta times a sine theta. So if I want dx d theta, I'm going to have to do a product rule. I can either distribute this, which is absolutely fine, totally okay, or if you don't want to distribute it, you can do it as a product rule right now. So if I do the product rule, I'm going to have u, which is 1 minus 2 cosine theta, dv, which is the derivative of cosine, so that's a negative sign, plus v, which is the cosine of theta, du, which is going to be the 1 derives to 0. The derivative of the -2 cosine should end up being a +2 sine, right? Because derivative of the negative cosine would come out positive sine. And then I'm going to go ahead and clean that up. So my dx d theta, and notice I am using this notation instead of x prime of theta because the AP asked for dx d theta. Use the notation the AP uses. When I clean this up, I'm going to end up getting a negative sine of theta plus a 2 cosine theta sine theta, plus another 2 cosine theta sine theta. So the answer I'm going to get for my dx d theta is whichever version of this you want. I usually like to put signs in front, so I'm going to say 4 sine theta cosine theta minus a sine of theta, right? So that's my dx d theta, and that's half of what I was asked to do. The other half of what I was asked to do, is to find y prime, or dy d theta. So my dy d theta is going to be exactly the same pattern, except I'm going to do it with the y formula, right? So I'm going to get u, which is 1 minus 2 cosine theta, dv, which will be a cosine theta, plus v, which is a sine theta, du, which is going to be that same 2 sine theta we saw the last time we did it. So I'm going to get that this is a cosine theta minus a 2 cosine squared theta plus a 2 sine squared theta. And I don't really think it gets a whole lot better than that. I mean, you could clean stuff up if you want, but I don't really think it gets much better. So any version of that would be fine. The version on the AP Solution Guide is honestly not much better than that at all. In fact, arguably, they just stopped right here. So either of those would be fine. Okay, so that's how I would find my dy d theta and my dx d theta. All right, part C. So for part C, I'm actually going to use both of these formulae, which is kind of tricky and obnoxious of them, so but we're going to make it happen. So they ask us to write an equation in terms of x and y for the line tangent to the graph of the polar curve at the point where theta is pi over 2. So here's the part that's kind of frustrating. I'm really, I want to use these formulae because they were a pain to get, and I don't want to have to lose them, so I'm going to cheat and shift my board over. So anytime I'm asked to find the equation of a line, I need two things. I need a point, x comma y, right? And I need a slope, which in most cases is my dy over dx. So the reason I mention that, and I'll inch this over a little bit more for a sec, is I can use these two equations to find x and y, right? So if we go back for a second to my x equation, I know that my x, right, my x is r cosine theta, and my y is r sine theta. Well, I have a theta now. I know that theta is pi over 2. So if I use this formula that I have, I can find both the x and y coordinates. So I'm going to go ahead and be kind of a lazy bum and erase this, even though I'll regret it, but I just don't have enough space otherwise. So let's go ahead and find my x coordinates. So I know that my x at pi over 2 should be my r, which is 1 minus 2 cosine pi over 2 times cosine pi over 2, right? Well, that means that I get a 1 minus 0 times a whole bunch of 0, which means that my x coordinate is 0. When I want y of pi over 2, that's going to be my 1 minus 2 cosine pi over 2, which we've already seen, times a sine of pi over 2. Well, that is going to be a 1 minus 0 times a 1, and so I get that the point for my line should be x comma y is 0 comma 1. Again, the point for your line is always an x comma y. The next thing I need is the slope. I'm going to call that mt for m tangent, and that's dy over dx. But since we already found dy d theta in part B and dx d theta, we're really just putting dy d theta on top of dx d theta. So what I want to do is to find my tangent slope, my dy dx, evaluated when theta is pi over 2, is just going to be, I had it as a 1 minus 2 cosine of pi over 2 times a cosine of pi over 2 plus a 2 sine of pi over 2 times another sine of pi over 2, which we'll deal with in a sec. And on the bottom, I had that this guy was a 4 sine of pi over 2 cosine of pi over 2 minus a sine of pi over 2. So we're going to clean those numbers up a little bit, and it does require a good amount of unit circle knowledge, but I get that my tangent slope, so all the cosine pi over 2's get wiped out as zeros, so this whole chunk at the top ends up being a 1 times a 0, so that's a 0. This is a 2 times a 1 times a 1, so I get 0 plus 2 on the top. On the bottom, the 4 sine pi over 2 cosine pi over 2 gets wiped out by the cosine pi over 2, so I get a 0 minus a 1. Looks like my tangent slope is a negative 2. So once I know my tangent slope is a negative 2 and I have my point, I'm just going to write my answer in point slope, right? So I take my slope, I take my point. The video got cut off at the end, so I'm just going to walk you through the last bit of the solution. So we have a point, 0 comma 1, and we have a slope, negative 2. So we're going to put those two together in point slope and do y minus 1, because y minus the y value equals m, which is negative 2, times the quantity x minus the x value, which would be x minus 0. This is the best possible answer. It's fine if you want to clean it up and put it in slope-intercept form, which would be y equals negative 2x plus 1, but you don't want to go from a right answer in point slope to accidentally multiplying or adding wrong and getting the wrong answer in slope-intercept. So just be mindful. Less work is better than more work. When possible, stop when you have the right answer.